Hello everyone, this is Dr. Madhura Mandar Fadke. In this video, I am going to discuss about the important concept of big data analytics, that is MapReduce. So let us start. As we all know, to process the huge amount of data, which we called as big data, we use the open source platform Hadoop. Hadoop ecosystem comes with several core components, out of which the two major components are storage component and then the processing component. For storage, Hadoop makes use of HDFS, that is Hadoop Distributed File System, and for processing it makes use of a programming paradigm known as MapReduce. In this video, I'll discuss about working of MapReduce. So MapReduce, as the name indicates, it comes with two major functions known as map and the other one reduce. With the help of MapReduce, the system manages parallel execution of several tasks together. To execute this task in parallel, the system makes use of two functions, map and reduce. So coordination of this task, this is also done by the system. Now when we execute this task in parallel, chances are there that some of the task may fail. So this failure is even handled by the MapReduce paradigm. Now to understand the working of MapReduce, let us consider the problem of counting the number of occurrences of each word in a large collection of documents. So input to our MapReduce paradigm is collection of documents. Now the thing is, can we do this in parallel? Obviously yes. Now to count the number of words in a document, we can write a program without using MapReduce. So over there we are not using parallel processing, but then since the input is huge collection of documents, it would be better if we execute it in parallel. So to do this, we'll divide the documents among several workers. Now these workers, we call them as either map worker or the reduce workers. Initially, we'll divide the input into number of splits and assign each split to one of the map worker. Now each worker will parse the document to find all the words, and finally it will produce the output, which is word count pair. In between, the pairs are partitioned across the workers depending upon the word. For each word at a worker, it will locally add up the counts so that we'll get the total occurrences for the given word. To have the clear idea, let us consider this particular. Here the input consists of 5 different documents. These documents are divided into 3 input splits cause we are having 3 mapper worker here. So each input split is assigned to a different map worker. Map worker will take this input and try to produce the key value pair for the given input split. In between we have the intermediate files, that is splitting, merging, combining, etc. Finally, the reduce phase consists of reduce workers. Reduce workers will combine similar words together and generate the output file. So this is the overall execution workflow for any MapReduce program. The master node coordinates the working of map workers and reduce workers. The thing will be more clear with this particular presentation. So actually we are dealing with some input and then we are trying to show the data flow for different MapReduce phases and finally how the output is generated. So initially in the input document we have several words. Few of the words are occurring more than once. So our intention is to count the number of occurrences for each word. Here the input is divided into three input splits. So we are using three different mappers. Now for each mapper, key value pair is produced. Key is nothing but the word itself and value indicates occurrence of that particular word. In the next phase, we combine similar words together. That is, as can be seen here, in the first block, we combine bus word. In the second block, we combine car word. Third block, train. And finally, plane. After that, we sum up the count for similar words. So this gives me 3 occurrences of bus, 2 for car, 2 for train and 2 for plane. And finally we combine it together to produce our final output. So this is the complete data flow for a word count program using MapReduce. So MapReduce comes with two functions, map and reduce. It is widely used in several applications like indexing, searching, classification, recommendation system, data analytics, etc. It is implemented by Google and Hadoop for Pig, Hive, HDFS and then HBase. The important feature of MapReduce is it is a programming model that supports large-scale distributed computing and parallel processing. So this was introduction to MapReduce along with one working example. Thank you.